So from now on, we are going to study specific to the pumps, that is centrifugal pump. Till now, we have seen general pumping system and the modeling of how we will get the net head provided by the pump. From now on, we'll have centrifugal pump, which are the specific first type of pump. So in general, for any fluid machine, we have three main parts. The first is the volute casing, that is the stationary casing for the machine. Second is the stator, which is the stationary blades or stationary part. Rotor is the rotating part of the fluid machine. So these were the constructional features which are very much similar to Francis turbine. And but the thing is, over here we have radial outward flow machine, and over there it was radially inward flow machine for Francis turbine. So what's happening for a centrifugal pump is the radius is increasing because radially outward flow is happening. Radially outward flow means as it goes outward from the center, the radius is increasing. Since the radius increases, the flow area increases. Flow area increases, that means since the fluid is of constant density, the mass flow rate is going to be constant, should be constant, density is constant, area is increasing, that means the velocity should decrease. And by using Bernoulli's equation, since the velocity decreases, the pressure increases, that is the static pressure is going to rise. So coming to stator, that is the first part. The second part, volute casing, is not of very much importance. That acts as diffuser. We'll see at diffusers at the last. So now coming to stator. So the objective of stator is to convert, there should be a T over here, sorry. Convert kinetic energy to pressure, and they are called as diffuser again. Their purpose is to diffuse. And for turbine, stator convert pressure to kinetic energy, called as nozzle. Over here, the opposite thing happens. They convert kinetic energy to pressure. Now coming to rotor. Rotor earlier was called as an impeller. Now it will be called as a rotor. Or over here also we can call them as impeller. So for turbine, they were called as runners sometime. So in Francis turbine, let's again reiterate. In Francis turbine, we have radial entry and axial outlet. While for centrifugal pump, the opposite happens. Entry is axial while it leaves radially outward. And the entry of pump is called as eye of the impeller. That is the center point from where the fluid is going to come axially inwards. Impeller adds kinetic energy because it is the rotating part. It adds kinetic energy to the fluid by pushing the fluid through movement from rotor. So increase the kinetic energy, and it will also static pressure head also increases. And reason I said earlier. And this is because increasing cross section area and centrifugal action also happens. Since the velocity of the blade is also changing, the change in velocity of blade also leads to a centrifugal action. So from impeller, we go to the stator, that is the diffuser vanes. So the stator or diffusion vanes can be skipped. So if we have space or economic constraints, we can skip the stator, and the volute casing in that case can act as diffuser. But there should be some diffusion because we have increased the kinetic energy of the fluid. So somehow we want to convert the kinetic energy to useful pressure rise. So that's the purpose of stator or the volute casing. And we say them at scroll also sometimes. That is second terminology for diffuser section. So scroll is the casing itself performs the diffusing action. So with diffuser, when we have a diffuser specifically, it increases the cost because we are increasing the part. It needs some space, and it increases the efficiency of conversion of kinetic energy to the pressure energy. If we do not use diffuser, the cost will be decreased, but the space is also less required, and efficiency also reduces. Shroud is another term. Shroud is also some kind of covering to a blade is provided, so we have better flow. Now from the next video, we'll look at velocity triangles.